Welcome my friends and dear students. Welcome to my channel Talking Physics with P.R. Sarkar, that's me. So today we are trying to learn about the electric field and its direction and the Coulomb force application. So in the previous lecture we go about the Coulomb force and its direction. If you do not see yet, then please go to my channel, that is Talking Physics with P.R. Sarkar, and watch it. After watching this video, comes to watch this video so as the concept will be more clear to you. So today we shall know about the existence of electric field. At first we know that what is electric field. If we take a charge Q, then it produced an effect of its own, which is called electric field, E field or electric field. Every charge around it produces a field. So how we know the existence of this field? If we take another charge Q0 at a some distance from Q, then a force will be exerted on Q0. So this force expresses that this charge Q produces a field around it. Now what is the value of Q0? Now if this charge Q, which is called source charge, if this charge Q produces a field around it and also exert a force on the charge Q0, which is called test charge, then it is obvious that Q0 also produced an effect so that the electric field and the force of Q will be affected by Q0. So this cannot be happen. So in this case Q0 to be vanishingly small or infinitesimally small, so that it does not affect the force or field of E. So in a word, we can see that if we place a charge in an if we put a charge, whether it is plus Q or minus Q, it exerts a force on a unit positive charge, which is called test charge, and this is called electric field. So if we take the definition of electric field, then we say that the electric field is the force on a unit, force per unit on a or per unit positive charge, which is called test charge. It is always positive. So electric field is the force per unit positive charge experienced by a vanishingly small charge at that point. This is the definition of electric field. So electric field is the force per unit positive charge expressed by a vanishingly small positive charge, which is called test charge at that point. So electric field E is equal to force F divided by Q0. But here, as we say, Q0 is vanishingly small, so we can write it here, limit Q0 tends to 0. this is the exact definition of electric field. In many books it is written that E equal to F by Q0, which is not correct, because if we do not take Q0 as infinitesimally small or vanishingly small, then its effects must be affected the electric field of Q. So we can always mention that Q0 is vanishingly small and its limit is Q0 tends to 0. So we can know the definition of electric field. Now, what is the significance of electric field? What is the significance of electric field? So, if we put a source charge Q in any place, then it will produce an electric field around it. Now, if we take a unit positive charge Q0, which is very small compared to Q, then it will produce a Coulomb force F. But if we take Q0 at some closest distance or any farther distance than the initial case, if we take Q0 this distance, so the electric field intensity will be different. If this is E1, this is E2, this is E, electric field intensity will be different. And electric field intensity is a function of R. So when the distance from source charge is changed, the magnitude of electric field intensity is always changed, so that electric field intensity is called a vector quantity. It is a function of distance R from the source charge. Also, the electric field definition, we can now derive the expression for electric field. So, for a radially, it is also mentioned that for a radially symmetric, that is for a sphere, if we place a source charge Q at the center, then as the direction or radius is same, so the electric field will be same in any direction. It does not vary with R. It is same for a sphere. The electric field intensity at each point is same, so it is called spherically symmetric. So for a sphere, the electric field intensity is fixed or same at spherically symmetric. Okay, for a sphere, So we can now define the definition of electric field. We can know the definition of electric field. Now we can take the expression of electric field. So electric field expression of E field. So suppose a source charge and test charge, source charge is plus Q and test charge is Q0, are separated in air by a distance R. Then the force exerted on Q0 due to Q is, as per Coulomb's law, 1 by 4 pi epsilon naught Q0 by R square R cap, where R cap is unit vector directed along Q to Q0. R cap is a unit vector directed from Q to Q0, that is from source to test charge. So the electric field intensity E equal to F divided by Q0. F divided by Q0 is 1 by 4 pi epsilon naught Q divided by R square R cap, or magnitude of electric field intensity is 1 by 4 pi epsilon naught Q by R square. That is, E is inversely proportional to R square. If we take a plot of electric field versus E, we can get a rectangular hyperbola. Okay. So the magnitude of electric field is Q 1 by 4 pi epsilon 0, Q is by R square. Now what is Q? The source charge, and Q0 is test charge. So in the final expression of electric field, Q0 is not involved. So electric field is depend only and only source charge, not the test charge. If we asked that if a deuterium, that is 1H2, is expressed or separated by an alpha particle, that is, we know alpha particle is helium nucleus, then what will be the electric field of helium on helium nucleus due to deuterium? So as the electric field is due to deuterium, so here the source charge is deuterium and the test charge is alpha particle. So here the electric field is only depend on the charge of deuterium, that is 1 by 4 pi epsilon 0. Deuterium charge is Q, that is 1.6 10 to the power minus 19 divided by, if they are separated by 1 angstrom, then it is 10 to the power minus 10 square, and the unit is Newton per coulomb or coulomb inverse or volt meter inverse. Both are equal. Newton per coulomb or volt per meter or volt meter inverse, Newton coulomb inverse is the unit of electric field. I hope you know the basic properties of electric field. Okay, so we know that the electric field is nothing but the force of the source charge on a unit positive charge placed on the same field. Either it is the source charge is positive or negative, but the test charge always be positive. And electric field is a function of distance r. It gives the coulomb force on a test charge, and also it does not depend on test charge, it is always depend on source charge. Let us do a numerical for our better concept. So if two charge particle plus 1 microcoulomb and plus 2 microcoulomb are separated by a distance of 1 centimeter, then what will be the electric field produced by each of charge particle? So we can write that the electric field produced by 1 microcoulomb is E1 and electric field produced by plus 2 microcoulomb is E2. So it is 1 by 4 pi epsilon naught. As the source charge is plus 1, that is here 1 into 10 to the power minus 6 divided by r square, that is 1 centimeter. It is SI unit, so we can write it as 0.01 meter square. Okay. So as the force is, as the charge, two charges are positive, so the electric field is along the direction of force, that is along this one, along right side. So 1 by 4 pi epsilon 0 is 9 into 10 to the power 9. So the value of E1 will be 1.8 into 10 to the power 7 Newton coulomb inverse. 1.8 10 to the power 7 Newton coulomb inverse. So also the value of E2 is 1 by 4 pi epsilon naught. Here the source charge is plus 2, so the value of E2 will be along this direction, because this charge produces force, a repulsive force which is along the opposite side of E1 is 2 into 10 to the power minus 6, 0.01 square, that is 9 into 10 to the power 6 Newton coulomb inverse. Okay. So this is the electric field produced by each charge separated by a certain distance. Okay. Now we go with another example. Suppose two charge plus 2 charge plus 1 microcoulomb and plus 4 microcoulomb are separated by 30 semi distance. Now, what will be the net electric field due to these two charge will be 0. E net will be 0 from at how far distance the resultant electric field is 0 from plus 1 microcoulomb charge particle. Okay, I repeat the question. Two charge particles plus 1 microcoulomb and plus 4 microcoulomb are separated by a distance of 30 semi apart. At what distance from the plus 1 microcoulomb the net electric field will be 0. So, let us assume that at the point P, which is at a distance x from plus 1 microcoulomb charge, the resultant electric field will be 0. So, this distance is, that is, if this is A and this point is B, so the distance AP is x, so this is 0.3 minus x, we can say it in meter and this is in centimeter, you understand it very easily, 0.3. So, the intensity of the electric field at point P due to plus 1 microcoulomb is given by E1, which is nothing but 1 by 4 pi epsilon naught 1 into 10 to the power minus 6 by x square, which is along the value of E1 is along this direction because the force is repulsive here, so it is along AP direction, and the force, the electric field due to plus 4 microcoulomb is 1 by 4 pi epsilon naught 4 into 10 to the power minus 6 divided by 0.3 minus x square, which is opposite direction to E1, E2, that is, it is along PA direction. So, as the net electric field is 0, so the resultant of these two must be 0. So, we can say that E1 equal to E2. So, if we put E1 equal to E2, then 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 is cancelled. Then we can get 4 by x square is equal to, we can get 10 to the power minus 6 by x square equal to 4 into 10 to the power minus 6 by 0.3 minus x square. Okay. As the resultant intensity is 0, so the electric field must be equal and opposite. Okay. So, we can say E1 equal to E2. 10 to the power minus 6, 10 to the power minus 6 cancel out. So, 4x square equal to 0.3 minus x square, or 0.3 minus x equal to 2x plus minus. So, we can get that 0.3 equal to plus 2x plus x 3x, or x equal to 0.1 meter. X equal to, we get 0.1 meter, and for the minus sign we can get x equal to minus 0.30 meter. But this cannot be possible, because if this sign is negative, means if this distance is 0.3 meter, so minus 0.3 means the place is left side of plus 1 microcoulomb at a distance 0.3 meters. So, for this charge the value of E2 is along this direction, and also if we place the charge, if we place the point at P which is left to plus 1 microcoulomb charge, then in this case E1 will be also in this direction. So, the resultant intensity will not be 0. They are add up and gives a resultant intensity which is non-zero. So, we can not go with this answer. So we can go x equal to 0.1 meter. So at a point 0.1 meter from plus 1 microcoulomb charge, 0.1 meter, the resultant intensity PE will be 0. So in this way we can solve any numericals related to electric field intensity, and also gives the dimension of electric field, that is dimension of electric field is given by force by charge, that is dimension of force is mLT minus 2 by charge is AT, that is mLT minus 3 A minus 1 is the dimension of electric field. Okay. So wherever we say that in which place the electric field will be 0, then we can find out the electric field for each charge and then just equate the two electric field, we can find out the distance. In the next day we can go with system of charge, that is more than two charges, that is the charge are placed at a vertex of a triangle or vertex of a square or rectangle, and do with the resultant electric field and find the resultant electric field. So for today we shall go with this video. If you like my channel, subscribe for next interesting video. In the next day we can in the future days we come with more interesting video for both class 11, 12, JEE and NEET. Thank you for supporting you. Thank you very much.